Right, so we're back again with Brian the robot. We're going to try and finish this off. So I thought I would show you what I've done in the in-between time. So I wanted to find out a way of getting a charging hole, a charging port into Brian. And so I decided to use this, what are these called? Panel mount USBs, I guess. And I've stuck it into the back of his number plate, and that seems to work really well. All I did was Dremel rotary tooled, I don't know, whatever the disc cutting thing is. This thing, I did that on here very gingerly, and then I cleaned it up with a Stanley knife type deal, one of these things. And I drilled some holes through, but I used a Sharpie on the end of the screws so that I could mark it out on the other side to drill through. So it's not quite center, but I'm not really bothered. I think it's fine, and that's actually a perfect place for it to go. So this this sits in here. If I just push that in, it won't go in all the way though. So I need to cut some posts off, but it will be on the back of Brian. So we're going to do that today. I really don't have a lot of time left because it's now the 22nd, so it is almost Christmas. And this is a present for a 3-year-old kid who probably won't be very happy if he doesn't get this at Christmas. Anyhow, I've also changed my circuit from using one of those nanos to just using an AT-Tiny85. Come in a little bit, I guess. And we're running off this battery here, but I've decided to ditch this because it didn't quite fit in very well, and instead we're going to be using one of these really terrible, they're not really terrible, these are 14500 batteries. They're AA lithium ion batteries, so I'm going to use it in this little holder, and this one will, I mean, it says it's 900 milliamp hours. That isn't correct, so I discharged this down to about 3 volts and then charged it again, and I got 500 milliamps in, which, you know, is less than the 700 milliamps this one has, but it's more than enough. This thing draws about 40 milliamps, so this will last for a good long time before it needs to be recharged.
Hello, Toby.
So it has a couple of phrases.
What did you learn today?
So he says, "Hello Toby, what did you learn today?" Those are the 2 phrases that it starts up with, and then a button press moves it on to the next track.
Robot Master.
And there's a software debounce on the button. And he's got some jokes.
What you are up above them, eat your vegetables. What noise does a lion make?
Okay, his voice changes a bit.
How much wood could a woodchuck chuck? If a wood, did you know there are 8 planets in our solar system? Mercury, Venus, Earth, our home, Mars, Jupiter, Saturn, Uranus, and the last one, Neptune. Let's not talk about Pluto. When the moon is in its furthest
So he's got some
orbit,
facts,
it
he's got
will
some
do
jokes.
call a dinosaur that is sleeping. A dino snore.
So anyway, he's got lots of little phrases in there. There's 24 in total, so that should keep him busy for a while. And hopefully by the time he's got to the end, he's forgotten what it said in the start. So just from an AT-Tiny85 using software serial to ping across to this device. Someone mentioned in the other video that you could use one of those, is it DRF robot ones? The little MP3 player ones. Well, I've got one, but I think I blew it up with 5 volts rather than 3.3 volts, so I'm not using that. I'm using this one instead, and it should be fine. I'll be able to throw this on a bit of strip board, and hopefully I'll be able to fit it inside here. So let's get the speaker out of there. So if I trim these pins down, I should be able to slot this in here and have the AT-Tiny85 sitting there on top of the speaker. Hopefully that'll work. I might take off this audio jack. What are they called? Connectors? I don't know, whatever. It's only on SMD soldered, so it should be fairly easy to rip off. And then I can solder directly to the pins on the back here to get our speaker output. So it should be able to have everything contained in here, which is brilliant, and it means that I only have to use this bottom section for power. Now, when this is together, let's just do that now. When this is together, we've got a completely round section at the top here. Let's focus on that, shall we? So this completely round section here. And if I just pop on the retaining hood, let's call it a hood, and we place it into the base, you can see that it has a limited range of movement, and that's because there's these little pegs on the rounded bit that stop it moving all of the way. And it can only move a little way like that. So actually, I think I might be able to cut a hole in that little round nub there and feed power through that. And hopefully there's not too much of a range of movement for it to cause any issues. So if I take it apart, you can see that there's actually a little bit of space in here, so I can get rid of some of that. And then I'm going to do something terrible. I'm going to use my iron to burn a hole in it rather than cut a hole. I wouldn't recommend doing this, but luckily for me, I have a, oh, do I want to use that one? I think I've got an old tip somewhere that I can use, so I'm going to use that to burn a hole in there. So that should be fun. All right, I'm going to get to it. First off, we've got to cut these sections off. So a bit of eye protection required here. So make sure you wear stuff like this, and we'll focus down. I've got to take the eye protection off to do the focusing. That should be good enough for you to be able to see. Now this is going to get loud, so sorry. But we've got the old Dremel here. And we're going to be using it just to cut this stake off here. I think that's the one I need to cut. This thing is really unwieldy. Do you know what? I don't even know if that is actually a cutting disc. I haven't got a clue. I don't know how to use this thing, so we'll cut the other side off as well. There we are. Now we should be able to pop, get all of those bits. Should be able to slide that in. Hey, look at that. There we go. So that's worked out quite well. And once it's screwed in, it should, oh, it doesn't appear to want to stay together very well. Is there something else affecting it there? No, I think it just needs to be, ah, there we go. There was just something slightly wrong with that. So there we go. I've got the glasses on still. I can't tell if it's in focus. There we go. So that looks all right, doesn't it? So we'll just have that as a, what is that, a USB type B. So that plugs in there, brings the power in. I'll cut it off about here and feed the cable up, and we'll glue our battery. We can take this apart now. This battery fits in much better than this big old fat battery. It's easier to glue down. I'll be able to just put some hot glue in there, glue that in. This can be sitting on the top with the power going in. It's going to be great. I'm really looking forward to it. So I'm not sure how much more of this I'm going to record because I need to get on, and it's a bit difficult to record it and do this at the same time. So I'll be back when I'm at another stage. So I'm just sort of melting my way a bit through this plastic. They both look okay now. Oddly enough, it appears to have cleaned up this iron a little bit. It was really, really bad before. Let's just give it a bit of solder so you can see it's still pretty shiny. It works fine. I got rid of this tip because it was really shit. Never mind, it seems to work. And now I just need to sort of use a Stanley knife. Where is it? There it is. And we're just going to shave off the bit on the top here. Right, so here it is with only one cable at the moment, but threaded through, so you can see it's coming out the bottom there. And then we're going to pop it in here. So let's feed that cable inside there. So this is in fact going to be 2 cables in one. And where's the base? There it is. And then it will be secured with a screw. And you can see that the wire moves a little bit, but it's just because it's moving around between 2 posts here. I don't know if I can show you this. It's very difficult to zoom in on. So let's see if we can do it. So you can see there's the base of the cable. And you can see it hits a post there, but in fact, oh, it's so hard to show you. There's plenty of room for it to maneuver without sort of shearing against anything. So I'm quite happy with that range of movement and how secure those cables will be. So I just had a major F up, and I'm going to tell you what it is, because boy, oh boy, was that silly. So what I did with this is I took off the, oh, you can't really see that. There we go. I took off the JST connector and the headphone jack, and it didn't work. It stopped working. And I just thought, oh God, I cannot get another one of these in time for Christmas. So I decided to look up the pinout for this. It's an 8002A amplifier. Looked at the pinout for that, pulled out one of these PAM 8403 modules, and I soldered directly onto the outputs of this IC, which is kicking out the negative and positive signal that's going to the amplifier. And I still got nothing. I didn't really understand what it was. And then I tried to find the schematic for this, and I thought, hang on a minute. I ripped off a pad or two on this headphone jack thing, and I thought, well, maybe one of them was connected. So I looked it up, and it turns out, here's a little picture of it on your screen. It turns out that when you have the jack in, it disconnects a couple of the pads. And I thought, hang on a minute, headphone jacks automatically disconnect circuits, so it might automatically disconnect the output for the speaker. And that's exactly what it was. So with the jack removed, the usually closed switches that are there were then open. So I've had to jumper them across really poorly. It looks horrible, but whatever. It's now working. So if I plug that back in.
Hello, Toby. What did you learn today?
Phew. Wow. Well, I thought you'd like to know that it isn't that easy. Oh God. Well, we're coming to the evening now. I've been working on this for about an hour, and I have to go out shortly. So I think we've got pretty much everything done. I've got my power done. I've scraped, in fact, you can probably have a look at this. Let's come in a little bit. So I've scraped off the blob here. I've got where the switch is. So this is it's not actually a momentary button. This is one of those carbon switches, you know, where it's got like a wiggly thing underneath and a carbon bit on top. And so it's like a resistive switch essentially. So it's not two contacts touching. So it gives a resistance of about 200 ohms. So I'm pulling that down, the output of that down. Am I putting it down? Pulling it down, yeah, with a, what's that, 2.2K resistor. And then that will be my switch contact that goes into my microcontroller. I've disconnected the speaker, so we can test that out actually shortly and see what it sounds like in here. We're almost there.